Okay, I spared you watching me erase and rewrite and reformat. I know the writing isn't too neat up here. It's probably tough to read, but you have a typed copy, so this was just for me to keep me on the right track as we went through these names. I'm going to try my best to give you what I did last time, where I'm identifying what about these words makes me do what I do. Like why I set them up the way I do. So here's another dozen, and hopefully this will help give you the full picture on nomenclature. So, nitric acid. I see that in both of those. I know that if it says hydro, that it's going to be H and just whatever the other element is. Chloric says chlorine. H and Cl, because hydrogen is +1, chlorine -1. Oh, so nice and neat. When I see nitric, I know that it's an acid, so it'll still have H. But nitric isn't HN. It isn't H3N. Because it's an IC ending, it's going to go with the nitrate ion. Hydrogen is +1, and my nitrate ion, when I look it up, is -1. So H and the nitrate ion, HNO3. There's no 2 or 3 or anything there because hydrogen is +1 and nitrate -1. You only need to know hydrochloric, hydrobromic, nitric, and sulfuric for the final. And those are pretty straightforward. They're all one hydrogen except sulfuric, which has 2 because the sulfate ion is -2. So let's look at these next ones. Nickel 3 bromide. I know I went down this column and then down that column. I think I'm going back to that, but I saw 2 acids written at the top and figured I would do those together. So this Roman numeral in nickel 3 bromide doesn't tell me how many I have. It tells me that nickel is +3. I don't need to look it up. I do need to look up bromine. I find it in group 17, so it's -1. Cross them. 1 nickel, because 3 times 1 is 1, and 3 times -1 gives me 3 bromines, NiBr3. Good. Potassium and sulfide. IDE means it's coming from the periodic table unless it's hydroxide. It isn't hydroxide. So I find potassium in group 1 and it's +1. I find sulfur in group 16 and it's -2. Just like this one. I need 2 potassiums and a sulfur. Ta-da! Good. Ooh, a prefix. Ooh, a prefix. So when I see a prefix, I look for those elements on the periodic table just to be sure. And I find sulfur in group 16 and oxygen in group 16 also. They're both at the right side of the table, so this is not a lie. This is nothing fancy. I have 1 sulfur. You don't need mono. So there's sulfur. Tri is 3, so I need 3 oxygens. When you use prefixes, you don't cross. Tri actually tells me how many oxygens I have, and don't forget to end it in IDE if you're writing them. Magnesium, what? Sulfate. These 3 in a row look at what all sulfur can do. Sulfur could be sulfide. Sulfur could start off this binary molecular thing with the 2 nonmetals and have a friend with a prefix. Or sulfur could be sulfate. ATE ending sends me to my ion sheet. I find out that sulfate is SO4 with a -2, just like I was saying with sulfuric acid, which is cool. I look for magnesium. It's in group 2. No Roman numeral needed. Magnesium was good. Look, it's my favorite. Equal but opposite. +2, -2. I just write them. I don't need any parentheses. MgSO4. KBN. Ooh, a prefix. Ooh, a prefix. Now, hydrogen's in group 1. But if I've got a prefix, remember, hydrogen's just, it doesn't like to follow rules. We don't really name it as hydrogen when it's an acid, but when I write the formula for dihydrogen monoxide, I think you're going to see that it's not what you think of as an acid. Some of you might already be chuckling at dihydrogen monoxide. Di is 2. Mono is 1. So there's some water, and remember we did formula writing. I was like, you do not have to name it dihydrogen monoxide, and at least I think 2 of you did. You know who you are. Dihydrogen monoxide, H2O. There you go. You still can call it water. I just wanted another example with prefixes for you. Almost done. Calcium, carbon, what? Carbon 8. Go into my polyatomic ions sheet with ATE. Calcium's group 2, there's no Roman numeral. Calcium's always +2. And a very special surprise, when I look up carbonate, CO3, it's -2. Equal but opposite, CaCO3. We good there? All right, let's keep going. Potassium, we already did potassium. I had the 2 acids together. I had the 2 potassiums together. Good. Potassium, group 1, +1. Chlorine, group 17, -1, another of my favorite. Equal but opposite, just KCl. Cool. Ooh, prefix. I look for chlorine and I look for oxygen. They're together, right side of the table. So I have this many chlorines and that many oxygens, Cl2, one we don't use too much, hepta, 7, Cl2O7, that's a thing. I've drawn that for AP Chem. Cl2O7 is a thing. I don't know why, but it's a thing. There we go. When you have 2 nonmetals, their prefixes tell you how many of that thing, there's no crossing. Lead, that's a 4. That looks awful. It looks more like a W in mine, or like a round thing. It does say lead 4 oxide. This one was tricky. This is sort of a tricky question, because we've just been crossing. When I cross these charges, lead is +4, oxygen's group 16, so -2. If I were to write that, I'm going to write it, but we're probably going to erase it. So don't think that my first answer is the right answer. I'm writing this to show you. If you just cross them, you would get Pb2O4. I don't like it. I'm going to tell you, did I mark it wrong? No, but you're going to get reduce written beside it, because 2 and 4 isn't the lowest ratio of subscripts. So I want rid of the 2. I want to divide both by 2. I want it to be PbO2. When it's 2 and 4, for a metal and a non-metal, lead is a metal. You know lead is a metal. When we get into these weird ones, like the Cl2O7, if that were Cl2O6, if that were chlorine hexoxide, dichlorine hexoxide, don't reduce. If it's got prefixes, don't reduce. If it doesn't, if it's a metal and a non-metal, you should reduce. I don't think, with the very few questions I had to give to nomenclature on the final, because I split everything up evenly, I don't see me getting into that fussy stuff more than I want you to know that this is hydrochloric acid, or that this means 3. There's way bigger ideas than me being fussy about lead oxide, but I wanted to show you lead 4 oxide and why I reduce. This one could make an appearance. We've talked about ammonium all year. I can't find ammonium on my periodic table, because it's not there unless you wrote it there. And I did. My periodic table says ammonium, so if you're using mine, your periodic table does say ammonium. Down in the lower left corner, and it says NH4+. It's also at the very top of most ion sheets, and if it's not at the top, it's on there somewhere. Ammonium's a +1. That's on my ion sheet. Hydroxide. This one was the one that this is like the trick of look on the periodic table for the endings. Because all the metals are IUM, and all the anions, the nonmetals, IDE, but hydroxide isn't on there. Hydroxide is on your ion sheet. It's -1, which is very nice. So, NH4OH. +1, -1, equal but opposite. Don't need any parentheses. Good to go. So there are 12 more examples, these of formula writing from names. This should really cover everything. Thank you, Clayton, for suggesting this, and hopefully other people have ideas too. I'll put this up sooner rather than later so that you guys can go through it for the final. Ask me if you have any more questions, and please send in any other topics that you want to see. Have a good one.